Thank you so much for your patience, everybody. We have Diyar here, and we are so excited to welcome him for Click, Plug, Compromise, a case study of a malware-infested camera. So give it up, everybody, for Diyar and welcome him. Thank you so much.
Okay, hello everyone. Thanks for having me today. Our talk is about the actual case study of a device that use it to deliver the malware into the computer devices. So actually, it's a case study. It's nothing fake. It's all based on the real incident that happened in one of the countries, I think in Europe or Middle East. Well, hope you enjoy my talk, and we will start explanation and reverse engineering the actual malware and the full delivery chain. So a little bit about me. I am Diyar Saadi Ali from Kurdistan, Iraq. I am actually the Kurdish Iraqi. I have quite to 11 to 12 years of experience in a computer security field, both defensive in general way. But it's been 2 to 3 years I'm working in a malware analysis and reverse engineering in general. In addition, I have spoke in a many international conferences, including Black Hat, DeepSec, COSAC, VulenCon, Arab Cybersecurity Conference, Solicon, and now I'm in a beside Budapest, and it's my pleasure. Well, how this story is started. So it's actually something unusual. One of them, my friend, posted in LinkedIn that he bought a camera devices from one of the platform called Temu, and when he attach it on their device, start monitoring and identifying suspicious stuff that happened inside the device. Even I personally removed the same malware from him device through a remote connection, anti-disk or mover. So that's an actual story. One of the friends bought a camera from Temu. When plugged into their device, the malware start installation and infected the device. Well, that's a product screenshot. You can search for Temu. You can get many cameras, many devices, but actually we don't know that it's secure or not secure. So actually nowadays the threat actor or maybe nation state or cyber criminals use many ways and many techniques to get a first foothold, or as we says in a red teaming, initial access on a targeted device or maybe a random devices. Well, I have separated this incident into different parties: basic static analysis and dynamic analysis, and network analysis and threat intelligence to have a full vision. I don't want to make stuff more complex actually, and with the talks I want to audience how to handle the incidents also, and how to perform the both static analysis, dynamic analysis, and network analysis at all. Well, actually, every analyst and every malware reverse engineer have their own methodology, have their own techniques and tweaks to handle the malware incident. Based on my experience, the first of all, when I got a incident, I want to understand the file structure, how many files we have, maybe which one be actual malware, because actually we know if the malware came to as a first stage, it will be detected very easily. Maybe it take only 5 minutes to 10 minutes to be detected by antivirus or EDR NG. But actually, if the malware will be in a different stages, 3 or 5 stages, it will be quite possible and challenging for antivirus engines to handle the incident. Well, the file structure of our incident is one VB script that execute batch script, this batch script. So this VB script equals to a2 blah blah execute this batch script. And this batch script actually drops this dot file. This dot file is contained an actual executable file. As you know from the file structure, we have a visual basic script or VBS script, we have a batch script, and we have a dot file. So the batch script, as I mentioned earlier, performing dropping operation. Well, actually, in a malware operation, the one sample is acted as a dropper to load a next stage. And the last file we have is a .dat file, an executable file. That's actual malware that we're trying to reverse engineering it. Well, that's a code structure. So actually, the first steps after the file structure, hash stuffs, and the file type identification, I'm gonna review the code structure, if the sample is a script based, because actually we have a script based malware, we have a document based malware, we have a plugin based malware, extension based malware, and so on. But actually, in this case, we have a script based malware. As you know, from here, the attacker set the object at wscript.shell to interact with the PowerShell CMD command prompt, and it start loading the .bat file, as I mentioned earlier. And if you notice here, we have a number 0. This argument means run in background. So when this Visual Basic script, VB script start executing, you don't see the bat execution stands. It's just something happen in background. Like how you cannot see the processes that run in a background. In this scenario, it's the same stuff. You see the VB script that pop up, but you don't see the batch file execution. Usually, when you double click on any batch file, the command prompt or CMD start popping up. But in this scenario, you don't. Okay? And here, during the analysis of batch script codes, we have something very interesting. First of all, we have something called chop, then 65001. This means it's, I think, applying the UTF-8 Unicode, okay? And then start open the USB drive Explorer. So when you run Explorer in a run or in a CMD or in a PowerShell, it start opening Windows Explorer. So it mentioned the USB drive. So this USB drive is an actual portable camera that the victim connected to him device or to her device. Well, in the next slide, we have something more interesting. It mentioned if not exist, if the system drive, this Windows folder is not exist, start creating it. But if exist, start removing it. That's quite interesting. That's mean if you simplify it, if you are already infected by this sample, it don't create any directory. But if you are not infected, it start creating directory and put the files and executable files into this folder and start executing it. Like here, we have an xcopy, okay, xcopy system drive, Windows system 32 print UI.exe into their specific directory, okay? And here we have a .dat file. I'm sorry. And the .dat file is contained the MZ header. As we know, 4D5A is a hex code or the identification for the portable executable file, .exe file. So to simplifying this stuff that we are talking about or mentioned earlier, this shell script is executing this batch script in a background, not in foreground. And this batch script is starting creating a directory into your C drive and start executing this .dat file. And this .dat file is contained portable executable file. That's actual malware. So the attacker is performing a good social engineering technique. Well, in a system 32 drivers, we have something called spool sv.exe. So it's a process, or you can call software, that responsible for printing stuffs. But the threat actor is create a fake process that mimicking actual spool sv.exe by calling print UI, and the attacker abuse it and cloned a same icon to their malware. Well, that's actual that file that I have imported into PE Studio. That's a malware initial assessment toolkit to investigate the import address table, strings, file header, DOS header, and so on. So actually, it's a MZ header. It's a MZ header, but with a DLL file. So it actually the .dll, .exe, .csr, .cpl, they are all MZ header. They are all portable executable, but they are start executing themselves in a different way. For example, if you have a .exe file, you just double click on it. Or if you have a .screensaver file, you are just double click on it. But if you have a DLL file, you have to use something called run DLL32 and then start mentioning your DLL file with a export function, for example, #1, and they start executing themselves. Okay? But actually, we have another dropped MZ header file. It's called universal tvs.dll. So we have two different DLL file. As you can see here, we have a virus total score of 53 of 72. So that's mean this sample is already analyzed or maybe reverse engineered by another researcher. But we start digging into a different perspective. Okay. Well, actually, every analysis contains string processes investigation. Well, in the string is we can find a good information inside it. That's true. Maybe some threat actor hide the string on the stack. So in this case, tool like bntks or stringis cannot be useful because the string embedded into the stack. That's called stack string. Okay. In this case, we have to use a tool called flosses that developed by Mandian that deobfuscate and extract the string from the stack. Okay. So we have something interesting here. For example, let me to zoom it. So here, as you can see, the attackers trying to conduct the persistence mechanism through task schedule. Okay, task schedule, create, tn, and blah, blah, blah. So that is mean the attacker is abusing the task schedule to maintain the persistence in the device. So what's the persistent mechanism actually, to make a simplifying it? It's a way that attackers stay on your machine. Okay, like leaving a backdoor on your machine actually. And there are many ways that threat actor is gain a persistent on your machine through startup, through run on runwas registry key, or through task schedule, and through services. There are many dozen technique. Even it can be happen through a recycle bin. So there are a lot of great information from this string that we are now investigating through it. Now we are moving into the dynamic analysis. So actually, there are a code by Santizu says, let your enemy reveal itself. So actually, maybe the threat actor put a junk code or the dead code or maybe unusable strings just to make your analysis harder and difficult and challenging. But when you move into dynamic analysis, the whole situation will change. Okay. So I have started executing the sample, the batch script, and using a tool called CMD Watcher. It's a great tool for monitoring the processes. For example, when you execute the PowerShell script, it starts monitoring it, and the capture the code, you can copy it and start investigating through it. Here's something very interesting. the active code page 55001. It's a UTF-8, and start dropping print UI.exe into system32 folder inside C drive, and drop the .dat file into it. And this .dat file is actually DLL file. Well, that's a sense before execution and after execution. In a normal device, usually we have only one Windows folder, but here we have a two Windows folder. In the right side, the second Windows folder is contain the malware stuffs, and the right side there are nothing, just a normal Windows folder that contain a default Windows utility like a notepad, CMD, calculator, PowerShell, and so on. Well, at this stage, before and after execution, there are another interesting stuff here. After 50 seconds, the fake Windows folder that created here will be deleted automatically. So you cannot see the whole scenario because you lost entire software that available inside the fake Windows folder. Well, there are something interesting here. We got a base 64 encoded PowerShell code, and we start decoding it. There are something quite interesting that most of the threat actors start abusing it. At this stage, the threat actor start putting their malicious software into exclusion folder inside a Windows Defender. So what the exclusion folder means inside the Windows Defender actually means Windows Defender, please do not scan this folder and this file. Even the Windows Defender start scanning entire disk C, entire your file systems, it doesn't and it don't scan the folder that applied and put it into exclusion path inside a Windows Defender. That's a complete keyword added and prevents exclusion path, the environment variable, system drive, Windows, and system32, and then it's put into exclusion path. That means if the malware and the actual payload will be in system32 or attacker drop it into there, it will not be scanned by a Windows Defender. But if you use external antiviruses like ESET, Kaspersky, and Avira, so on, it starts scanning and detected the malicious payload inside system32 drive. Well, there are another interesting point here is modifying registry and creating the service. Well, from the computer HQ local machine system current control set service, we have something interesting called image path and CV host -k. That's a actual command line for CV host processes, and we have a service name called X2705 0651, and that's an actual path. And we don't have such a service like that in a Windows operating system itself. That's something unusual. And the server state in a running state. So it's not stop it, it's not push it, it's in running state. Well, regarding to the persistent mechanism, as we mentioned earlier from the string analysis, the threat actor is abused task schedule to conduct a persistent mechanism and stay on the infected machine for the long time. Here we have something interesting. Let me zoom it. Start program C Windows System 32 console 0. As you know about it, the attacker is added System 32 Windows path into exclusion path from the Windows Defender. So that means it cannot be scanned. Well, we will start identifying the targeted processes. Okay, in a left side, we have the print UI.exe, that's a suspicious processes, but in a right side, we have actual legitimate processes. It's called spool fv.exe. There are something interesting here, actually, guys. If you look on the left side, you will see something interesting. C Windows, System 32, and cbhost.exe, while it's not available in actual spoolsv.exe processes. Okay. And here we have a cvhost.exe processes with a different process ID, and it's normal if we have multiple cvhost processes. Actually, it's a something normal, but we will start more digging it and reveal entire operation. So the DLL file, the dynamic link library file, as we are investigated earlier through the PE Studio, start injecting itself into cvhost processes. As you can see, there are dozen of cvhost processes here, but only one processes that communicating with the suspicious IP address. If I zoom for you, they are communicating with 40.94.31.213 and with the TCP protocol and port 18. That's mean it could be HTTP based protocol. Well, let's start doing some kind of threat intelligence and more digging into it. Well, actually, I started dive into the cvhost processes and find something interesting. -o xmr e1.nanopol.org. That's mean mining stuff. Actually, the injected processes communicate with the XMR miner. So based on that, we can 100% be sure that this malware sample is a crypto miner. As you can see here. ID name, USB, CPU, hashes, and so on. And actually, there are more interesting stuffs here. The injected processes cvhost.exe is downloading additional payload. As you can see here from the string is this is mapped into memory. Okay, there are a website called unvwx.com/un1 and /uusb.dat, and there are multiple domains with a different file. As you can see in the right side, the sample start downloading, and let's start investigate that also. Well, start. I'm sorry. Okay. Yes. Okay. Here. Okay. Well, after downloading the next stage of the payload that malware is injected into CVS processes, we were gonna start some kind of the basic network analysis. Well, I have downloaded Apache DNS. So the Apache DNS is a tool, I think, developed by Mandiant to simulating the network connection. So after executing the malware, the batch script, the VBS script, it start communicating with the unvwmask.com. That's an actual website that downloading additional stage. Well, I have decided to use another tool, not Wireshark, not Charles Proxy, not HTTP debugger, a network miner. Network miner is a great tool actually for forensic investigation, network investigation, and so on. Well, from this .exe, and that's an MZ header, it starts communicating with the suspicious host name, xmr.eu and nanopol. That's something unusual happening here actually. Well, again, in a Wireshark, dns.query.name to retrieve the DNS names, and they are again a nanopool domain that's responsible for mining stuffs on a infected machine. Well, there are something more interesting here. The IP address 45.94.31.230 start downloading another that file. As you can see from the Wireshark, you can just right click, follow HTTP request, or just go to the file, export object, and so on. You get the actual file, and you can just copy it, save it, and start reverse engineering it. Well, I start exporting the object and save it. And I have decided to make some kind of a threat intelligent and OSINT, open source intelligent, to make my report more comprehensive actually. Well, actually, the first stage on my OSINT and threat intelligent methodology is check the whois info, the domain registration. So the domain registration, the first one, I think registered on October, and the third one is registered on December. So that's a quite new one. Okay. Because when I created this slide it's not 2025, I believe. Well, check for the minor worker. Okay. So there are some platforms you can just put the minor ID and start get a graphics and analytics to have a more investigation and more workflows of your reporters and your scenario and your situation. And here we have something very interesting. There are two workers. One of them called N, and the other one called Reg00. And last share is a few minutes ago. And that's the rating. And that's a full scenario that you can see from the image. Well, I don't use a VirusTotal at all because it provides a lot of false positives. Even if you try to write a simple hello world in Python and start compiling with the PyInstaller and then upload into VirusTotal, it starts detecting as a malicious file. But actually, it's not. But to be a quite legitimate report and research paper, I have uploaded that into the VirusTotal. And there are 12 detection of the domains, and there are the 8 detection to the .dat file. And the .dat file actually is communicating with the unvdwx.com and UN1 universal, blah, 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 and so on. That's a whole scenario and whole reporters that give you a full sense about how this campaign operating. Well, I have started to conducting the passive DNS and related domains through the same IP addresses. And there are some other domains that performing the same operation, like unvduel.com, unvwx.com, and mcroomage.dev. There are 3 domains that related to a same IP addresses. Well, URL scan is a great platform, is a great website to for threat intelligence and OSINT. Actually, I have started to find a similar website is here to confirmation and validation for this passive DNS investigation, and that's a result. You can find different domains, different file names, and different IP addresses. Same IP address, different IP addresses, different domains for a same goal. Is the crypto mining. Well, the next domain is to download additional malicious file, unvwdx.com and unvdwdel.com. Both of them downloading a malicious payload, actually. So that's a communication network diagram. I will share the slide with yours later after the conference finish. And that's a whole operation that we have from the network communication diagram. And that's an infection chain diagram that's make a whole analysis easier. So the initial purchase, one of my friends bought a camera from the Temu device, plug it into the laptop computer, and the directory automatically pop up, media directory, product name, product root directory. We have a VBS file, batch file, .dat file, the batch execution, create a file and folder in the system32, malicious executable, and so on. It's a long diagram, but contain the full chain and the full report of our investigation. And that's a MITRE attack diagram I have created for threat intelligence team, for threat team, full vision about techniques and methods that threat actors used in this campaign. And that's all about my research paper. If you have any question, if you have any tips and suggestion, you can start asking now, and I'm happy to answer. And sorry for my English. I'm not a native English speaker, actually.
Thank you so much. If you guys have any questions for Diyar, please use the Discord chat. It'll be, I think, easier for everyone that way, and you can get your questions answered. So yes, thank you. Give it up for Diyar one more time. Thank you so much.